What is a function? Have you ever wondered the answer to that question? What is a function? A function is a relationship. It's a special kind of relationship between the input and the output, or you could say between two sets of numbers. It relates each input to a single output. So here are some examples of functions. F is a function, g is a function of x, and so is h. But most commonly, you'll see f of x as a function. Y is equal to f of x. So f of x could be anything. F of x could be 3x plus 5, that's a function. Y could be 2x minus 7, that's a linear function. These are all examples of functions. Now going back to this one, x is the input of the function and y is the output of the function. Now in order for this to be a function, for every input there has to be a single output. If you get two outputs for one input, it is not a function, it's a relation. So in order for a relation to be a function, there has to be one output for every input. The input represents the domain of the function, whereas the output represents the range of the function. Now let's talk about how we can make a function table. Let's say y is equal to 2x plus 4. If we plug in 1, or if we replace x with 1, we'll see that y is equal to 6. If we replace x with 2, we get a y value of 8. So for each different x value, we get a different y value. That's an example of a function. When x is 3, y is 10. Now consider these three function tables. Which one is not a function? Take a minute and analyze those three tables. Feel free to pause the video. So looking at the first table, all of the x values are different. So that's going to be a function. Now, you can have the same y value for different x values. That is totally okay. You still have a function here. For the second table, we do have a common x value, but they lead to the same y value, which is okay. For the third table, we have a common x value, but they lead to two different y values. That is not okay. When x is 2, y can't be 7 and 8 at the same time. And it needs to give us just one output, not two different outputs. So if we input 2, we want the function to give us one output. If it gives you two outputs, it is not a function. It's a relation, but it's not a function. Consider these 6 graphs. Which one represents a function and which one does not represent a function? Go ahead and identify each one as a function and the ones that are not functions. Feel free to take a minute on this one. So how can we tell if a graph is a function or not? There is something called a vertical line test. So if you draw a vertical line, if it touches the vertical line at one point, it's a function. If it touches it at 2 or more points, then it is not a function. So A, or the graph that is associated with A, is a function. The graph that is associated with B, that is not a function because it touches the vertical line at 2 points. So let's put an X for not a function. Now for C, that's a function. It touches it at 1 point. Graph D does not pass the vertical line test, so that is not a function. If you draw a vertical line anywhere on E, it only touches it at 1 point, so that's a function. And for F, we can clearly see that it's not a function. At this point, it touches it at 3 points when we place the vertical line at that location. So F is definitely not a function. By the way, for those of you who want more examples on functions, evaluating functions, dealing with composite functions, and like operations associated with functions, check out the links in the description section below. I'm going to be posting more video content there for those of you who needs to go deeper into this